Good afternoon, my people. In today's video, I want us to dissect the anatomy of Schrodinger wave equation in connection with formula of everything. Uncertainty principle has set a particular boundary, and so we're going to use that boundary as a gauge for the quantum suspension that we have in time energy wave model, which formula of everything was able to break in order to break the symmetric nature of time energy wave model to arrive at the solution that we have. And that solution is to have static nature of position and static nature of momentum to arrive at ideal solution. And so we're going to use this video to get to know about how formula of everything is able to unify quantum mechanics to classical mechanics. So now, with no further ado, let's go into it. Let's dive deep into it. So right here, this is the Schrodinger wave equation. And so we're going to start with I. We have that I to be imaginary number, which is square root minus 1. So I call that flip induction of complex system beyond the wave boundary. As we progress, you get to know that more. So we have here h bar there, and the h bar is having the Planck constant divided by 2 pi. And so the value that we have is the smallest energy chunk that can exist in quantum system. So this sets the scale at which quantum effect becomes significant. So that is so important. So now the value that we have here, derivation of psi to time, that tells us how much the wave function psi changes with time. And so we have this term to be kinetic value, and then we have this term to be potential value. So now we can see that the variation of position multiplied with variation of momentum must be greater than or equal to h bar divided by 2. So that gives us this value, and these values serve as the boundary at quantum level. So when you look at this chart that we have here, we have h bar divided by 2, and that is the boundary limit. Now the value that we get from time energy wave model, the suspension value that we have at quantum level, is bigger than the value of that suspension. So now by breaking this suspension, we should be able to